Good morning, Hacksters. Sorry for the delay. We are a little bit slow out of the gate today. We had a guest drop out, but today's Hackster Café, you don't have to go without interviews. I'm going to highlight some of the amazing technology from our guests over the past year. So, uh, as you may know, since you're here, check this out. We've got the playlist of Hackster Cafe episodes, which is our weekly interview show where we talk to amazing people from the hardware community who are building really cool stuff. And I've pulled out some of the specific ones that have sent us hardware over this amount of time. You can find it at bit.ly/hackstercafe. Very easy. No accents or anything needed. Then, so recently, last night, I released this video for assembling the Thumby, featuring our guests, Ken Burns and Ben Rose from a recent Hackster Cafe. They sent us this tiny little gaming console. Let me show you this. And it does turn on. And I just learned how to program this with Python. The thing is that we often highlight people and their technology, but we don't often follow up and show you how it actually works and how easy it actually is to use. So this is the Thumby tiny, tiny gaming console live on Kickstarter right now, and you can now go look at the video for how to assemble and use it. This one doesn't actually need any assembly, but I love this little bouncing emoji tutorial that they have. Go watch the video. It's super cute. Who else do we have? We also have Kitty Young, who has created these Bluetooth badges, which feature LEDs, RGB LEDs. They have touch sensing. They have a LiPo connector. They have a haptic feedback motor. And they have Bluetooth connectivity, as the name implies. They have a little pin on the back so that you can connect it to your clothing. And they have USB-C and all kinds of other stuff. Kitty kindly sent these to me, but I haven't yet had a chance to assemble them. So part of what I wanted to get feedback on today is, which of these things are you most interested in seeing next? Not on a Hackster Cafe. We're going to be back with more interviews soon. But specifically on a Fundum Friday or such a thing. These actually have a touch sensor as well. Oh! Yeah, check that out. Amazing. And I haven't had a chance to run through her excellent tutorial on DF Robot, but you can go get these on Kitty's website. You can go check out the link in the description below for where to find this video, which links to her Hackster project about it, BLE PCB Brooches. It's a collaboration between Kitty and DF Robot, and they have a full tutorial up. Very excited to check that out. We've also done a ton of interviews with Kitty, and she recently completed a Kickstarter for a number of different tech fashion projects, including like solar panel clothing and things like that, which you can find on her website. Not only that, but we did a follow-up interview where she talks about how she uses her company to contribute back to sustainability causes, to education causes. One of the things that she did in the wake of her recent Kickstarter success was that she sent out a poll for what people wanted her to donate to, and she ended up donating to Reinvented magazine, which is all about women in hardware and technology, and yeah, a bunch of other amazing organizations that were chosen by the community. So I think Kitty is a great person to support. Go check out the interviews. She's such a cool person doing amazing things, and I want to show you how to use this on an upcoming Friday. Plus, we got her quantum computing and some physics, very accessible cartoon book, which I'd also like to share some of. But you can go find that on her website as well. So that's Kitty Young, and we had Ben Rose and Ken Burns from Tiny Circuits. Who's next? Oh, one more thing. This video is going to culminate in me assembling the Oskitone Scout kit. So stick around for that. We're going to have some soldering as well, which I love. Okay, so Charlene Gonda was one of our guests in February, and she sent me this cool 2020 finisher badge, which I never really got to show off. And this is basically, she made, it combines laser cutting for the baseboard, laser cutting and etching for the pen itself, which is made of this gold tone acrylic with the black backing. It has an on-off switch. Yes. She's an amazing person who makes all this amazing LED art. It's jewelry, it's like wall decorations and stuff. If you're really interested in sort of stylish polished, finished-looking electronics, then go check out our interview with Charlene. And I treasure this badge, not only for the fact that she's a friend of mine in person. She sent us this, as well as the fact that the sentiment behind it. I I really hope we get one for 2021 as well, because that's absolutely necessary. But yeah, she combines 3D printing, laser cutting, and all kinds of different technologies in one project here. And so go watch that interview if you want more information on how she did that. We also have an interview from August with Joshua Zimmerman of Brown Dog Gadgets. This is a really cool company. They actually do a lot of robotics kits, and a lot of them are Lego compatible. I had an interesting question for them because I thought that Lego is very litigious about how you can use the word Lego. Like, you have to use bricks or Lego brand bricks, or like, with all caps styling and stuff. But they get away with it somehow. Lego allows them to produce Lego compatible electronics. So not only do they make a bunch of cool pieces and parts that you can stick onto your Lego and use to connect electronics together, including like a coin cell battery and LEDs and things with built-in resistors on the LED pieces, which was an interesting point that I didn't realize before. Check these out. But they also make this maker tape, which is a form of conductive tape that's made with nylon. Let me give you the close-up desk view on that. More stuff coming up. But yeah, check this out. We've got this piezo buzzer here. We've got some LEDs, and this is all Lego compatible. And then you hook them together with this maker tape. Or conductive thread. It actually came with conductive thread as well. But it's basically a nylon coated tape, and it's Z-axis conductive, so it's conductive through it, which means that you can just layer it on top of itself to make connections, which is something that a lot of copper tape you can't do. Very exciting. And then they have these boards modules as well that you can hook those up to your Lego. So go check out the Brown Dog Gadgets. Ooh, I'm gonna put those in the back in the wrong places. The Brown Dog Gadgets interview with Joshua Zimmerman from this August. And again, if you're just joining us, you can find all these interviews at bit.ly/Hackster Café, or of course you can just go to Hackster.io/videos and you'll find all of them, as well as a bunch of other videos. Okay, now finally, one of our most recent ones from September 28th was Tommy Marshall of Oskitone. This is a really cool project. You probably already saw this coming up, but this little synthesizer is made by Tommy Marshall, and we're going to put it together today. But before we jump into that, we'll have a lot more rambling to do about it. One more that I forgot. The Ardu Boy by Kevin Bates. This is super special. Unfortunately, it doesn't work right now because I took out the battery because it was having some issues, but we're going to come back with it and do some more projects. I do have a video up of using this, as well as an interview with Kevin Bates. And the cool thing about that is that he actually works for us now. Kevin is now running our contests. So if you go to Hackster.io/contests, you can go pester Kevin. But more seriously, you can, if you go to our videos, you can find our interview with him and learn a bit more about the Ardu Boy. I also have an example video up where I put together a small program to run on the Ardu Boy. It's a very cool handheld gaming device, and I couldn't show Thumby without showing the Ardu Boy. They're both very wonderful. This one is programmable with Arduino and MicroPython. This one, the Ardu Boy, is programmable with Arduino, I think. I think it's an Arduino Leonardo in there. I could be wrong. The chip, or the way that it runs. Oh, it's just an Atmega 32U4, but I think it shows up as a Leonardo. And then the Thumby, of course, we just released a video on how to program that as well. I love these things. They're so cool. Okay, so back to today. What we're doing is, if you came here looking for an interview, I understand. I'm also sad that we had a little bit of a scheduling problem, but what we're going to do is do an assembly video. We're going to put together this Oskitone Scout, and my question for you is, should we next on our Friday mailbag segment, should we look at the Brown Dog Gadgets Robotics Kit, or should we look at Kitty's BLE Flowers? And I'm going to be posting a poll on that to find out who's going to be up next, because I think they're both really exciting. I've had them both sitting around for months, and I want to get to them as soon as possible so that we can check them out. One of them is a wearable platform, and one of them is a Lego platform. But without further ado, let's put together this Oskitone synthesizer because it's very cool. And you can find the assembly instructions on GitHub. Actually, yeah. So we went to oskitone.com/guides. And now we're going to go to the Scout repo. And hopefully it will tell me how to assemble it. Here we go. Detailed assembly steps. Required, we have the Oskitone Scout Synth DIY Electronics Kit and its 3D printed parts, soldering iron and solder specifically for electronics. Oh, I guess, yeah, you do have like jewelry solder and stuff, so don't come in here with your like silver solder. Wire stripper or cutters, 3 AAA batteries, and headphones. Recommended, multimeter for debugging, PCB vise or helping hands holder, solder sucker or desoldering braid, patience, patience, and patience. There's 3D printing. We've already got the 3D printed enclosure, so we don't need to do that. It's a beautiful banana yellow color. And then you can check which of the files you've already printed. This is a really good piece of documentation. You've got some notes on here about 3D printing it. Okay. Detailed PCB soldering instructions. Component colors. The ones that you get may look different in the guide. Resistors are labeled with colors, capacitors with numbers. We know about that. If you're not familiar with that, you can check out an online guide to resistor color labeling, which shows you their values in colored stripes. So for example, brown is equivalent to 1, then it goes like red, orange, yellow, or like 2, 3, 4. So, and then you can learn how to read it because each stripe, depending on which stripe it is, it can represent either a direct number, like a 1, or a power of 10. So it could mean 2, or it could mean 2 zeros tacked onto the end of the number. And it's a little complicated, but once you get the hang of it, it's not too bad. Ceramic and electrolytic capacitors. There are 2 kinds of caps in this kit. So ceramic and electrolytic. The electrolytic ones tend to be polar and have like a plus and minus side you have to be careful about. The ceramic ones tend to not care. IC chips, integrated circuit chips, are static sensitive, so they tend to be packaged in little anti-ESD bags, anti-electrostatic discharge bags, which enable you to protect them from static. And also can be used in interesting ways because they're conductive. ICs in sockets. Each IC chip comes with a corresponding socket with the same number of pins. You'll solder the socket to the PCB, not the chip itself. This prevents overheating the IC with the soldering iron and makes it easy to switch a faulty one out. I love this about kits when you have a socket to solder in instead of a chip, because it's a little less compact if that matters, but in the end, you know, it's a lot easier if you put the chip in the wrong way, or if you know, it just to avoid overheating the IC with your soldering iron. Component polarities. LEDs, batteries, and electrolytic capacitors have positive and negative leads, like we just talked about. Resistors and some other components, like the ceramic capacitors, are not polar. IC orientation. We also have orientation on the IC chips. So the sockets tend to have a notch in them. Chips tend to have either a notch on the side of pin 1, or they'll have a little divot, a little dot on them that shows you which side is pin 1. And let's get started. Cool. I may mostly go my own way on this because what I tend to do, as many people do, is start with the shortest components first. And it's quite possible, actually, that Tommy has arranged the guide this way. It makes sense. So you'll put in like resistors and things first because they're sort of flat against the board. And what that does is it enables you to easily reach around those components in order to solder the taller ones later on. So you'll usually start with the really flat ones and then sort of build up from there. I'm going to be using an Omnivice, which is a really helpful type of vice that I learned about from people I interviewed on Hackster Café as well. If you're interested in that, who was it? I think it was Stephen Hawes who told me about the Omnivice, so you can look up his interview as well. And I can vouch for the awesomeness of this device for holding PCBs. You've got a really pleasant screw mechanism on here, and then you can adjust the height and things. Thank you, Stephen Hawes. And I'm going to be using a brass coil and some lead-free solder and my Weller soldering iron. So let's get started. I'm actually going to follow Tommy's instructions on this because it's probably for the best. Okay, so we're going to assemble the battery pack first. Let's pull out all our things on the desk and have a look. Oskitone Scout. Here's most of our 3D printed enclosure. For those just joining us, we had some technical scheduling difficulties, and so we're doing a review of recent interview highlights and the technology that they've either sent me or I've ended up with in other ways. And we're going to be assembling one of those, which is this Oskitone Scout synthesizer. We have a nice little note that says, "Thank you and congrats on your new Scout from Oskitone." And I'm going to see if we can focus a little bit better. That seems to be about it. Okay. We have a beautiful anti-ESD bag. Turns out that Tommy puts all of this together himself, including heat sealing the bags. It's really interesting if you're interested in building your own kits. Go check out Tommy's interview because I learned a lot about how professional it can look, even if you're doing everything by hand by yourself. The PCBs he gets made by others, though. Here's our main circuit board PCB. We're going to put a row of buttons down here, a couple of chips on there, and things like that. We've got some awesome stickers. We've got batteries, a couple of interaction aids, and some chips and sockets in a rail. Let's get this off the desk. Okay, so here's our enclosure. Set that off to the side. This side. And we'll take out all of these pieces. Just dump them in a nice big pile there. So there are some pieces here that are very obviously for batteries. We've got these springs, more springs. Oh. And another spring. The rest we'll just leave in a happy little pile over here. We're going to be Bob Rossing it today. Everything's going to be happy little electronic components. Yeah, so then we have our Omnivice. And let's see, where's our battery holder? Oh, it's in here. Huh, cool. Oh, what a cool idea. So it's together, but it's separate. Oh, this is an interesting little sort of snap-in method that he's done here. Check this out. It doesn't have an actual like little overhang. Well, it does. It has like the tiniest little overhang that goes into a slot here that enables it to connect in very securely to the enclosure. That's so cool. Let's have a look at what we're supposed to do here. So, insert the tabbed battery contact terminals. The springed contact goes into the slot with a negative indicator. And do these tabs stick up? No, they go down through. All right. So let's show you that. There we go. So there's a little tabbed spot with that's sort of short. It's got a hole through the bottom, and it's got a negative marking here. So we're going to stick that in there. Whoop. Grrr. That's what tables are for. There we go. Pretty easy. And then we're going to put this positive one in the other small slot here. Using our table again. There we go. And now, a couple of springs. These look about the same as each other. Let's check. Oh, you have to fold their tabs over to hold them in place. Smart. Just checking that this button faces inwards. Okay, so checking the orientation here against the picture. We're going to put this in here. He has some quite good explanatory photos here that are really helping. I've never put together a battery holder before, so this is pretty cool. Oh, it really works! Check that out. Worked very easily. Now the other one. Looks like this time it goes on top of that triangle. Go in there. And points toward the middle. Ah! Go back. Cool! Yeah, I've never put together a battery pack before. That's exciting. Let's see what we do next with this. Add wire. Cut your ribbon cable into pieces of about 7 inches and 3 inches. So when he says ribbon cable, that's this multi-stranded cable. It's been a while since I've done an assembly video, and it feels so nice. I hope y'all are enjoying this as well. Again, this is a kit that was sent to us by one of our recent interviewees, Tommy Marshall, who does the Oskitone synthesizers. Let me double check that these are actually not supposed to be stuck together still. Cut your ribbon cable into 2 pieces about 7 inches and 3 inches. Okay. So it should be about 10 inches in total. And I'm going to use my evil mad scientist ruler here. Let's make the 3-inch piece be all stuck together. And use my clippers here. So now I want to take the 7-inch piece and thread it through one of these holes. But which one is it? With the battery holder oriented so its positive contact tab is on the left and negative on the right, thread the 7-inch ribbon cable through the hitch on the left about halfway through, and then split the bottom pair of wires. Oh, good, because I already split them. There we go. Cool. Thread the darker wire of the now separated pair through the channel on the bottom. Oh, cool! And also, he shows us how those tabs are folded down. I wasn't totally sure about that, but it looks like they just go inward. Is that right? Oh no, they go outward. Okay. So let me grab a little pliers real quick. And I'm going to bend those tabs outwards. Trying not to squish the spring inside. That should work fine. I don't think it has to be down all the way. Just enough to sort of hold that in place. Okay, so now we take the darker wire, which is this purple one, whoop, and run it down this channel. Cool. You can tell that this has gone through a lot of iterations. He's probably taken feedback from a lot of people. A common convention is to use the darker color for negative and the lighter one for positive. Strip a 1/4 inch of the insulation off of that right wire and solder it to its contact tab. I'm going to use my... Woo! I'm dropping things. I'm going to use my wire stripper here. Take about a 1/4 inch off. Doop. I've done this enough times that I can kind of go by feel and just get the outer casing. What I'm going to do is sort of twist it between my fingers in order to make it stick together. And usually I just hold this part and then twist the body of the wire, and that's a lot easier than trying to twist those narrow strands by hand. So solder to its contact tab. I might try and thread it through here. No, it'll be fine. And stick it through the hole here and take my soldering iron. Get it nice and fresh. I'm not putting this in the Omnivice because it doesn't really make sense yet. Let's solder this. Here we go. For something like this, where the pieces are sort of held together, but I could use a third hand, for soldering, I can just bend the solder into a little arc shape and then bring my joint up to it. So I'm going to put a little bit onto the iron for thermal contact. There we go. And bring both iron and components to the solder. There we go. And I'm making sure to add solder directly to the joint rather than to the iron, because that means that it's definitely flowing into the joint and not just going to the iron and giving me a less than ideal solder joint. Okay, so that is connected. We had a little bit of melting, but not too bad. So now we're going to separate and strip the other side of the wires. Oh, cut the other wire to meet its tab, then strip and solder it. Okay, cool. So that means this one. We're going to cut this one to meet its tab, strip it, and solder it as well. Probably didn't need to switch tools for that, but another 1/4 inch. There we go. It's not too big of a deal if I don't twist this one, but I'm gonna do it anyway. There we go. Do our same little trick with the bent solder. Oh, no, I'm totally melting this 3D printed case. My poor aim. But there we go. It's soldered in. Okay, battery pack. Now we have these. I think it wants us to strip and solder those other ends. Separate and strip the other end of the wires. Make sure they don't touch. Cool. The nice thing about these wires is that you can just sort of pull them apart with your fingertips. Some ribbon cables are a little tougher and you'll have to like take your snips, your side cutters, and sort of cut down the middle. But for these, I was just able to pull them apart. Going to bend them outwards, far away from each other. Strip those. I love this. This is my favorite way to spend a morning. For my job, anyway. And also, I love Hackster Cafes. So any of those that you watch, it's just absolutely the best part of the week. Okay, so now we're going to put these batteries into here and test it with the multimeter, which hopefully I have accessible. You do have these handy guides on the enclosure itself to show you which way to put the batteries in, which is pretty cool. So now those are in there. Each of these is 1.5 volts, so we should get 4.5 volts total out of the battery pack because they are in series. Let's check. Positive is going to be the lighter one. Doop. And then negative is going to be the darker one. Doop. Might have clipped onto the insulation there. Huh. Oh. Okay. It's on the wrong setting, but it is giving us... It seems to be giving us wrong values. Strangely. Are you connected correctly? We've got positive soldered on here, negative soldered on there. And for some reason, it doesn't seem to like me. Are these all in the correct way? Yes. Negative, positive, negative, positive. I'm going to chalk this up to me usually knowing my way around a microcontroller, a multimeter, but for some reason today, it's not doing its thing. but I fully believe that this is 4.5 volts coming out of here. So we're going to twist those together and make sure that they stay far apart from each other. There we go. Multimeters are super handy for doing stuff with resistors. If you're not totally sure about your ability to read them yet, you can always check with a multimeter. He's got it on the 20 volt setting. Let's just double check that I wasn't doing something foolish. I think this multimeter also needs some new batteries, so. Number 1. Number 2. No, you're just straight up not. Strange. Well, I'll deal with that later. Okay, what's next? Power up, solder the LED at D1. So now we're actually getting on to the stuff with the PCB, which is very exciting. Where is D1? Here we go. So D stands for diode in circuit boards. You'll usually have U for ICs or chips, and then C is for capacitor, R for resistor, and a number of other ones that you won't come across as much. There's SW for switch. So that could be buttons, that could be actual switches, that could be toggle switches, anything like that. Here we go. D1, we're going to solder in that LED, but which way up does it go? Goes, okay, so here he's got it so that the LED is on the top right. So clearly it's this way up. When we solder it, we're going to flip it over. We want it to be straight up and down with no leaning, and we want to make sure which pin goes in which hole, because this does matter for LEDs, and we want it to be the third one on the right. So let's do that. We're going to bend this, and it wants to be these two up and those two down. Let's see if we can get this in. Woo! Come on. Ahaha, that's not bad. If I do say so myself, I'm just going to sort of snug that down in there, straight up and down. Okay, and that's a pretty firm hold, so I'm just going to leave it without bending the legs out further and flip it over to solder it. Be nice to get a little closer in the future. Maybe I can manage that. I'm keeping my fingers pretty far away from the join, so when I'm holding the solder, I sort of adjust it to make sure that there's a couple of inches of space there in between. And we're going to go ahead and cut those off. I like to wait until it's a little bit cool and then sort of grab it with my fingers so that they don't fly off everywhere. There we go. Very neat and tidy. Our first attachment on the board. Oops. Kevin asks, I like the helping hands thing you have. What is it called? This is an Omnivice. It's very nice. It helps a lot with soldering stuff. It's very heavy, super steady. You've got an adjustable height on there. And I found out about it from Stephen Hawes, who was one of our interviewees a while ago, talking about PCB art. So we've gotten the LED as vertically close as possible. Now we're going to solder the sliding toggle switch SW1 and resistor R1, 220, red, red, brown. Okay, let's go find those. And we may have to come back to this one, which is just fine with me, honestly, because I think that doing this whole thing in one go, along with narration, might take a while. So we've got this switch here. And here we go. Is this red, brown, brown? Red, red, brown. 220 ohm resistor. So like I was saying, the way that resistor numbering and coloring works is that you've got this color code, and brown stands for 1 and red stands for 2. So in this case, we have 3 bands of value and 1 band of tolerance. That gold band down there shows us that, I forget whether it's 5%, 10%, 1%, but that's our tolerance, how accurate we can expect the value to be. And the red, the first red, how to say this? Okay, so the first 2 stripes are just plain digits on their own. And the third stripe tells you how many zeros to tack onto the end, aka how many tens to multiply it by. So we have a 2, and a 1. And the first 2s are just 2s, and the 1 is the number of tens we add on, or we multiply by. So that's 2, 2, and multiply it by 10, you get 220. So that's 220 ohm resistor. I never get tired of explaining that. So this is going to be R1, I think. Yes. And where does that go? Here. So we're going to bend down these legs. And we're going to put it through. There we go. And on the bottom here, I'm just using my finger to push the legs outward so that it stays in place, which that switch does not do. Okay, so the deal with this switch is that this might be a little challenging. I'm going to use the table to do this. It doesn't have any easy way to bend legs out to hold it in place, and it doesn't have any friction fit so that it just kind of stays in there on its own. And I can't hold it in place while I do a tack solder because this case is grounded, so that would burn me probably. So what I'm going to do is I'm going to put it on the table and tack solder down just one connection very loosely. Oh man, and I can't do that because the LED is in place. Oh my gosh. Okay, so I'm going to build up a little support system here. Okay, what I'm going to do is solder on one of the pins, the inner pins, that is not connected to the ground outer shell. And then hopefully I won't burn myself. And this is just kind of a very quick and dirty way to attach one of the pins. Ordinarily you wouldn't want to apply solder just directly from the iron. But that will hold the switch in place. And then I'll solder in the rest of the pins. And then I'll come back and fix that one. See how I've just done this really messy join here? It's really gross. We'll fix that in a second. Okay. We'll do a pretty one here. Pretty one here. Oh yeah, that wasn't very pretty. There we go. Pretty one here. Pretty one here. And then we'll fix our ugly child. There we go. Could use a little bit more there. There we go. Some nice concave joins. Okay, and now we're going to go do this resistor. Hey, go away. Once again, we are assembling the Oskitone Scout synthesizer kit. If you scroll back to the start of the video, you will see some of our highlights from recent Hackster Cafés. And a lot of them have shown off some really cool hardware. I think we're going to be doing Kitty Young's BLE brooch next because we got some votes for that. Not during a Hackster Café. Today is an anomaly, but during our Friday mailbag session. Okay, so we've got 3 components on here, and we've put together the battery pack. Okay, so now wire the battery pack to BT1. Thread the other side of the ribbon cable. Interesting. Is this just for... Huh! So we're just going to test this by connecting it to a button pad. That's interesting. Okay. Wire the battery pack to BT1. We're going to stick it through. Oh! Oh! BT1 is for battery, not button. Duh. Okay. Huh, cool. And we've got a little built-in strain relief system here. So when you attach wires to a board, it's very easy for disaster to strike when the wire comes under stress. Like it can get bent back and forth, it can get pulled on and stuff. And the thing that I'm going to actually take out one of the batteries here because of what we're doing. we're going to put these wires together and thread them through a hole. So what Tommy has done here is make a little hole in the PCB that you thread the wires through, and then you solder them onto the board. And I'm making sure to put the dark wire through the negative hole and the light wire through the positive hole, as he has said. We're gonna do this for about 9 minutes more, and then we'll be at an hour, and then I promise you we will come back and finish this on a subsequent MCU mailbag Friday. Yeah. So we've got our strain relief hole here. We've got our wires threaded through and stuck through those holes, and then I'm going to try and hold them in place while I solder these on. Which might be a little tough because that battery pack wants to put weight on it. Okay, that's pretty good. It's also nice to not have the battery pack connected because these are getting soldered into holes directly next to each other, and it would suck if long leads caused a short as well. So I advise you to do that before attaching the battery pack. Just take out one of the batteries so that you don't have a continuous circuit and you're not going to get a short. There we go. Okay, so now we're going to see if that battery comes on, or that LED comes on, if we move the switch to the right spot. Okay, so here we go. Hey! Hooray! Okay, now the other deal that I forgot to mention with this LED is that it's an RGB LED. It can do red, green, and blue, and any combination thereof. That's why it had 4 leads instead of just 2. It had 1 long ground lead, which means that the other 3 are positive leads for red, green, and blue, and they're all connected to the same ground. So it's a common ground one, or common cathode, I think. And then there are RGB LEDs that are the opposite of that, where they have a common positive side, and all the rest of the colors, all the colors share the same ground line. Quick sip of water. Okay, and then presumably if we turn this switch off, yeah. Ha, cool. Ah! Okay, so we got to Blinky. That's good. Hello, world of hardware. So let's go and see what our next. Yes, it is bright. Power off before continuing soldering. Very important. Boot the microcontroller. Solder some capacitors on, an oscillator, and some resistors. Okay. I'm going to try and get to this before we quit here today. And again, we'll be back later on. Okay, so we got to find capacitors. 220 microfarads. That's one of these big ones. With paper tape, you can either like rip them out or just cut them off. There's no reason to save the whole length of the legs. They do show you which side is positive, but you've also got this stripe on the capacitor that shows you which is the negative leg. So you don't really need to worry about that. And you're just going to cut them off anyway. So we're going to do C1, is that right? Yes, 220 microfarads. Nice little marking on the board there about which side is which. So the negative stripe goes to the negative side. We're going to do the same thing as with that resistor. We're going to bend the leads outwards. So that's C1. C2 is 0.1 microfarads marked 104. It's going to be one of these. Not this one. That says like 1609 or something. 104. Capacitors actually have a very similar value notation system to resistors. Instead of using colored bands, they just use numbers. But is it what? Picofarads, nanofarads? 0.1 microfarads would be 1 nanofarad, I think. All right, 104, maybe nanofarads. Okay, so this goes where? It is a capacitor 2, C2. So we're going to find that on our circuit board. Holler if you see C2. Here it is. Found you. Do the same thing. This one is non-polar. It's a little ceramic capacitor. Just goes in there. What else have we got? Oscillator Y1 and resistors R2 and R5. Oh, this is a really great tutorial. It tells you the number value and the color system for each resistor that you're using. Where's our oscillator? Y1. This is a tiny resistor. I'm actually not sure what the oscillator will look like. I don't deal with them much. My guess is that it would look like a little metal case. Here's our speaker. Like a quartz oscillator in a watch or whatever. I hope it's not lost. I've sort of decanted this kit into another container because the original packaging was a shipping box that I had to destroy when I unboxed it. Oscillator. That couldn't be. No, it's not one of these. Let me check the bag. Maybe there's a picture. Oscillator Y1. Oh, it is the big one. Okay, so it's this big blue guy. Cool. Oh, it's got 3 leads on it. Obviously, it's not a capacitor. Huh, interesting. It doesn't seem to be polar. So we're going to stick that in here. Yeah, there's no markings on the board that would indicate that it is polar and cares which way you put it in. I'm going to use both hands to get this nice and stable. There we go. Then we've got a couple of resistors to put in. R2 is a 220 ohm and R5 is a 10 kilo ohm, brown, black, orange. We already had one of these. Red, red, brown, 220 ohms. So R1 and R2 are right next to each other. I see why he's doing it this way. So, like I said, I usually... some people are going to get upset with me if I don't put the resistors in the same way, even though they don't care. For some people, it's like a style thing. So, I'm doing that for you. They're not perfectly aligned, but they are pointing the same direction. Where was I going with this? Oh, yeah, I do see why... like I said, usually I'll put in all the resistors first and all the low, like flat components like diodes and stuff. But I can see why he's not doing that, because he wanted to give us that hello world moment of making the LED turn on. I think that's really smart because it's kind of a long form kit and takes a minute to do. So it gives you a really quick burst of satisfaction and you know that it's working. Brown, black, orange, 10 kilo ohms. So, what do we learn about resistor colors? We learned that brown means 1, orange means 2, black means 0, and we learned that gold is the tolerance value. So, what we have here is, hey, focus. We have brown, which is a 1, black, which is a 0, so our first 2 digits are 1 and 0, and then we add on the third stripe's number of zeros. So that's a 3, so that's a 1, a 0, and 3 more zeros, 10,000 ohms, 10 kilo ohms. R5. Where are you? Right there. I'm going to solder these guys in. I'm going to try and tilt this one away from the chip because that will make my life easier later. Now let's solder this all in. And then we're going to put the chip on, and then we're going to say that's it for today. Oh! Dropping my solder here. Let's get that back. There we go. Okay, cool. Resistors. I'm kind of lazy. I just hold the whole roll of solder in my hand. Of course, as with any time you solder, whether or not you're holding the solder roll in your hand, you want to wash your hands very thoroughly. Even if you're using lead-free solder, it doesn't mean that it's non-toxic completely. You're not going to like eat a roll of solder. You don't want to like, solder with this and then go eat a sandwich without washing your hands or make your friend a sandwich or anything. So, doesn't matter if you're using lead-free. Still be nice and careful with that. I like that I don't have to change out my solder often because I just have this one big roll of it. I like to flick sort of the excess solder up the side of the leg there. It helps keep the join from being too blobby. Our focus is misbehaving as well. And then I also have my soldering iron cleaner stuck on the top of my solder there, which makes it very convenient. Okay, tips and tricks. Now we're gonna start at this end where the legs are definitely cooled. We're gonna snip them off, holding them down so that they don't fly away into our eyes and face and nose and pets and onto the floor and wherever else. I happen to have a little tin on top of my desk that's from some tea that I specifically use for just keeping on the desk so I can throw little soldered legs into it. Helps keep the workspace clean. That and like little stripped ends of wires and stuff. Like these guys. Yeah. Cleaning as you go. Okay, so one more thing here. We've got the IC to put on, the main Arduino IC. Very exciting. I'm going to bend this oscillator out a little bit again. So solder the U1 socket. It has a dimple at one end, which should match the footprint on the PCB. I should have zoomed this earlier. Okay. With the power off, carefully insert the Atmega 328. It will have a dimple and or small dot in a corner, which should match the socket. Again, those both sort of help you know which pin is pin 1 to help orient the chip, and I'll show you that in a second. Oh, this is so cool! I love this! This tutorial is really cool in that it gives you sort of checks along the way. It's not just like solder the whole thing together and then hope. It's like, no, we first put the LED on and we were able to check the LED, we were able to check the battery pack, and now we're putting together, oh, and the switch. And now we're putting together the part with the chip. So again, we've got this notch here. Notch in the schematic there, or the silk screen. Stick that in. It does not friction fit. It kind of does. But I'm still gonna... I'm not a huge fan of soldering it with this battery pack just dangling off of there. I wish the wire were a little longer so that I wouldn't strain it. And that wouldn't be a problem if my Omnivice were a little lower, but I can't get it any lower than this. Let me see if I can give you a little bit more close-up on this. Oh, and I'm going to rotate this. I specifically put some little rubber feet on the bottom of my Omnivice so that I could keep it from reflecting all this light. So it would angle. My focus is being a jerk. Focus. Focus. Let's get this out of the way. Maybe it'll like me better. Anyway, we're going to solder this on now. That's actually holding in pretty well. I'm going to push it into place. And yeah, now I'm able to just... I don't have to do that tack soldering trick from before. Which can also help if you are just uncertain about the positioning of a component. You can solder in one leg of it and then take a look from all the angles as it's held in securely. Then you can reposition and adjust it while melting the solder on just that one leg. And then once you've got it in the place where you like it, then you can solder the rest. Tack soldering. Best thing. So again, this is our last component we're going to put on, but we'll be back another MCU mailbag day, which is Friday. Today is just a sort of introducing you to some of the recent cool people we've had on Hackster Café, our interview show, weekly at 10 a.m. Pacific time, which would be an hour ago now. And you'll get to meet the people who make this cool stuff. So as I showed you earlier, if you scroll back to the start of the video, you'll see Kitty Young's BLE Bluetooth PCB brooches. You'll see we've got a garbage truck going by. Oh, there's our socket. You'll see the Thumby game controller. You'll see the Tiny Circuits, or not Tiny Circuits, the Arduboy game controller from Kevin Bates. We've got interviews with the creators of both of those, an interview with the creator of the BLE PCB brooch, Kitty Young, and all kinds of other good stuff. Let's get this IC in and test the circuit. I'm so excited. Okay, so where's our rail again? Oh, here we go. Rails often come with a little plug in the end that helps you keep everything safe and secure. You can just pull out the one that you need. And I'm going to save these for an upcoming Friday. And this one has both. So like I mentioned, pin 1 is going to be the bottom left pin of your IC. And often that will be marked with either a notch or a little dot over pin 1. And in this case, it has both. So that's cool. Oh, hey! I think Tommy must have done this himself. Usually pins that or chips that come on a rail will have their legs bent outward a little bit. Just that's how they come. And so you can use the table to kind of straighten those legs out a little bit. But it looks like they're already straight, so I should be able to slot this right in. Oh, maybe. Almost. Come on. Clap your hands if you believe in chips going in on the first try. Come on. Come on. Yes. Ah ha ha ha. Okay, let's make sure that all the legs went in. Yes, they did. Beautiful. If our focus would cooperate, then that would be a huge win. Come on. Come on. I'm going to do it manually because this is too pretty to miss. There we go. Here is our whole board so far. And what should happen when we flip this switch is that this LED should start going multiple colors. Let's see if it works. Hey! We've got green. It did a little bit of blue there. Show you again. Yeah, some cyan action there. This actually looks like cyan, which is a mixture of the blue and green colors. If you have red, green, and blue all going at once, then it'll look white, etc., etc. Huh, cool! Okay, so that has been part 1 of soldering together the Oskitone Scout synthesizer from Tommy Marshall, one of our recent guests on Hackster Café. Let's go and do a quick overview about that again. You can go to bit.ly/Hackster Café, all one word, all lowercase, to find all of our previous interviews with awesome people from the Hackster community. This is my sort of behind-the-scenes view, but you'll find this playlist with Ken Burns and Ben Rose of Tiny Circuits, the creators of that Thumby module. We just posted a video about that last night, about how to program it with MicroPython in their web IDE. We've got Kitty Young's Bluetooth Low Energy Wearable Tech Balloons, which are super cool. They're sold in packages of 2 so that you can connect them between like a mother and child, etc. Just have them linked together. They're so cool. They've got all these cool wearable tech attributes. You can get them online. Charlene Gonda's cool 2020 finisher brooch that we looked at. We've got Brown Dog Gadgets. We did an interview with them talking about their cool robot kits and their Lego compatible circuitry and their maker tape, which is a really cool utility for connecting together circuit boards without soldering or sewing or anything. We've got an interview with Tommy Marshall, the creator of Oskitone, like I talked about, and that's the thing that we were assembling today. And I also want to show you the one with our very own Kevin Bates. Here we go. Kevin now works at Hackster as our contests coordinator. Ooh. And you can hear about his journey with creating the Ardu Boy, which is that other little game controller console that I showed you. It looks like this. And it's also programmable. Very cool. I did a video on how to use that as well. So, very exciting. We've had so many amazing guests on the show. Sadly, I was unable to get someone scheduled for today. Behind the scenes specialness, I'm sure you understand. But we'll be back next week, and every week 10 a.m. Pacific with a new person to tell you about their hardware exploits and show off their cool technology. If you have anyone, always feel free to drop a name in the comments, and we'd love to feature the people that you are curious about, that you admire, you want to hear their stories, you want to hear how they run their hardware business and things like that. Besides that, we'll have a ton of cool people coming up. Stay tuned and hack on. Thanks for joining me today. It was really fun.